Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power of 16 times 9 to the power of 46. Now when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62, so it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40. We just take away the indices. So it'd be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. So to find the gradient, we need the formula or the equation in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6 because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared, and the force is given to us in the question. So what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78, and we must write down the reason. So corresponding angles, and corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle. are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in twos, so this will be 28, so the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus. And so we've got 12X. And then on the last bus stop, 19 passengers get on. So plus 19. Now for the second bus, well, we start with X and a further 5X come on. Because 5 bus stops with X passengers. So that's 6X altogether. And then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less. And the way we show that is with this inequality here. Now all we need to do is solve that inequality. And we've got x on both sides, so we look at the x's. We've got 12x and 6x, so we always take away the smaller amount. So we're going to take away the 6x both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got x is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for x? Now, it is tempting to write down 10, but it says x has to be less than 10. So the biggest number we can get that is less than 10 is 9. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down. But here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic quadratic function. There's a very specific way to draw an angle bisector, and you start off with a pair of compasses and put the point on B and then draw an arc from B. And it doesn't matter what the distance is, as long as it's kind of roughly maybe halfway between A and B. It doesn't matter what the distance is. And then at the 2 points, so here and here, that our arc intersects line AB and BC, we're going to draw another arc up here. So I'm just going to show you because it's normally easier. So an arc over here, and I'm going to do an arc from the other one over here. Then what I'm going to do is I'm going to join where the two lines join with where the two arcs join. And that is how you do an angle bisector. All of the arcs leave on the diagram because they are going to get you the marks. Arcs for marks. So to make estimates from a scatter graph, we've got to first of all draw a line of best fit, which would be something like this. And what we'll do is to find estimate of test score B, given the fact they got 25 on test A, means that we would draw a line up from test A at 25. Should be here and then across, and that's how we'd make the estimate. But look at where that is hitting our line of best fit. It's hitting it here. What do you notice about this position here? Well, all of our data is down here. We don't know whether this trend continues up at this point here. We have no idea. For instance, if you were to plot a scatter graph of height against age, we would see it would increase like that, but that line doesn't continue on forever. Like, you're not a 10-foot giant at the age of 30. You do slowly stop growing, and so we don't know whether the trend continues. So we call this extrapolation. So we say that the data has been extrapolated, and what that means is it is probably not accurate. So when you have the data outside the range of the data, when you have a prediction, outside the range of the data, we say it's probably not accurate. If it was inside the data, we would say it's interpolated, and that's actually quite accurate. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the two 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got to times the top by 4 as well, to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 and 3/20. And we can add the 4 and the 1 together to make 5 and 3/20. So the answer is 5 and 3/20. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line, and then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour, because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one. And the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got 2 of the 3 angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. When finding a sample of people, you want everyone in the population to have an equal chance of being picked. So in method 1, the fact in a lifestyle magazine might bias the people reading it, because there's groups of people that don't read lifestyle magazines. A poster up in the gym, again, there's groups of people who don't go to the gym. And midday in town centres, well, it might be on a school day, or it might be that you are skewing your data towards retired people. There's lots of reasons why a certain group of people won't be at a town centre at midday. The only one here that gives everyone an equal chance of being picked is this one here. Okay, so picking people randomly from the electoral roll. There are some groups of people who might choose not to be on the electoral roll, but looking at the 4 methods, this one is by far the most fair sample. We can rewrite this question as 2 over 3 divided by 20 over 1. So whenever you have an integer, it's just the same as that integer over 1. Now the rule is that we're going to keep, flip, and change. So we're going to keep the first fraction as 2/3, change the divide to a times, and flip the second fraction. Then we multiply the tops and multiply the bottoms. We can actually halve top and bottom here, and it does ask us to simplify it if possible. So our answer is 1 over 30. So angles and a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through two parallel lines, which are our two north lines. And therefore this angle here is going to equal this angle here. And the reason for that is that the two angles are alternate, they're z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons. So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. So factorise means to put it into a bracket. And it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u. And there's just a u on both of them I can factorise out. And actually, that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So our triangle says that speed equals distance over time, and average speed is the total distance over the total time. So when we're looking for average speed, we want to work out, so we're just going to write average speed or speed, and it's going to be the total distance. So the distance starts at 0, goes up to 30. So the total distance is 30, and the time starts at 10:15 and ends at 11. So that'll be 45 minutes, or, well, we should do it in hours, because the units we want in hours. So it would be 0.75. So 30 divided by 3/4 would be 40. So it's going to be 40 kilometers per hour. To find solutions for quadratics on a graph, all you need to do is find out where the graph meets the x-axis. Okay, so the coordinates this graph meets the x-axis are here and here, and that would be minus 0.8 and minus and 0.2, and they're also called roots. So I'm going to write the equation out, the formula out, and we're asked to make y the subject. So I'm just going to get my lines in, And so what's stopping us from having y on its own? Well, this minus 1. How am I going to get rid of it? Add 1 both sides. So we've got x plus 1 equals 9y. What else do we have that stops y from being on its own? Well, there's times 9 here. So we're going to do the opposite, the inverse, which is divide by 9 both sides. And to do that nicely, what we do is we just do it as a fraction. X plus 1 over 9 equals y. So therefore y is x plus 1 over 9. Whenever we solve, we've got to get rid of any fractions or brackets first. Now looking at this, there's no fractions, but there are 2 sets of brackets. We've got the set of brackets here, and we've got the set of brackets here. So we're going to expand them to get rid of them. And you can use any method you want. I'm just going to use this kind of grid method. So we're doing 4 times, and inside the brackets we've got 3x plus 5. So I'm going to times those out. 4 times 3 is 12, so that'll be 12x. 4 times 5 is 20, so that's going to be positive 20. And I'm going to do the same for the other set of brackets. Now on the outside of the brackets we've got to be careful here. It's not a 5, it's a minus 5. And inside the brackets is an x and a 2. So minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. So when we put it all together, we get 12x plus 20 minus 5x minus 10. And then the rest of it is just equals 52. So I'm going to start by putting my lines in because we're solving. And I'm actually just going to start by collecting the like terms on the left hand side. So 12x take away 5x is going to be 7x. And 20 take away 10 is going to be 10. Okay, now we need to get rid of the plus 10. So we're going to take away 10 both sides. So we've got 7x equals 42. And then we need to get rid of the times 7. So we're going to divide 7 both sides. So x equals 6. Factorising is the opposite of expanding. So instead of multiplying something out of a bracket, we're putting it in a bracket. I'm going to start just by putting the bracket down. And we're going to ask ourselves, what number can we divide out of 18 and 33? And we need the biggest number we can divide out of both of them. So we're essentially looking for its highest common factor. So 18 and 33, that would be 3. And there's no letter we can divide out of both of them because 33 doesn't have a letter. Next we ask ourselves, 3 times what is 18x? Well, 3 times 6 is 18. 3 times 6x will be 18x. Then we ask ourselves, what times 3 is 33? And that's obviously going to be 11. And you can expand that. 3 times 6x is 18x. 3 times 11 is 33. So we know we've got the right answer. So our answer is 3 brackets 6x plus 11. So we can write this as a fraction. So it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into 2 fractions. So 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method. So 4 on the outside, and we've got 2.84 on the inside. 4s into 2 don't go, so carry the 2 across. 4s into 28 go 7, and 4s into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide 2 powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the 2 minuses, the 2 takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number. So it's 10 to the power of 13, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it'd be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So we're told the length of this rectangle is u, and the width is u plus 2. Doesn't matter which way around we do it. And we're told the area is 80. So we can actually write an equation from this. So u times u plus 2, so that's the length times the width, is equal to the area, which is 80. So let's expand this. And what we're going to do is we're going to put everything to the same side. So all I'm going to do here is subtract 80 from both sides. And so we've got u squared plus 2u minus 80 equals 0. Now we're going to be using quadratics, so we're going to factorise this. And so we need two numbers that add together to make 2 and times together to make minus 80. So I'm going to put my brackets out. So we're going to have u at the start of the brackets. And let's have a think. So it's going to be 8 and 10. And one of them will be positive, one of them will be negative. Well, to add them together to make 2, the 10 will have to be positive, and then the 8 would have to be negative. And then minus 8 times 10 is minus 80. Okay, last thing is we get each of our equations equal to, each of our brackets equal to 0. So we can solve them. Let's just do this in normal colour. So u minus 8 equals 0. And let's solve that. And so we're going to add 8 both sides. And we've got u equals 8. And we're going to do the same for this right hand bracket. So u plus 10 equals 0. Get our lines in. And take away 10 both sides. So u equals minus 10. Now it might get confusing because it says find the value of u, but a length needs to be positive. So this minus 10 is not the correct answer. Our correct answer will be 8. And we can actually check this because if I fill in the value of 8, so we can have 8 at the top here, and 8 plus 2, which is 10. 8 times 10 is 80. So we know that we've got the right answer. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. So we're asked to express TQ in terms of P and Q. Well, we've got another Q here, because all of these are congruent parallelograms, and we have a P there. So if we're starting at T and getting to Q, we can go along this path here and down this path here. So we're going backwards down Q, in fact backwards down 2 lots of Q, and then the correct way down P. So it's either minus 2Q plus P or P minus 2Q. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do, but I think this is a really tricky question to do without a Venn diagram. So it says that they picked 2 activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle, because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2x, take away the 11 that we already know about. And the painting is the same. We know the whole thing is x. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be x minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So x minus 11 plus 11 plus 2x minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got x plus 2x, which is 3x. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. We're going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. In this question we have a right angle triangle and we know two of the sides and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here. And the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13. So we need to know what the total length around the triangle is. So we're going to add the 5, the 12 and the 13 we've just found. When you do that you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9/15. And therefore the property of female is 1 minus 9/15, which would be 6/15. Male on the second bus is 7/15. And so female would be 8/15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6/15 and 8/15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome would be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6/15 times 8/15. So 6 times 8 is 48. And times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4. And that will give you 16. Is it 4? No. You can times top and bottom by 3. And that would be 16/75. So either 48/225 or 16/75. There are a couple of different methods for drawing a graph, and we're going to do the cover-up method. So I'm going to start just by writing out the equation. And what I'm going to do is I'm just going to completely cover up, and I'm going to do this with a little highlighter maybe. I'm going to cover up the minus 3y. I'm just going to cover up the y term. And so what that leaves me with is 10x equals minus 30. So if I get my solving lines in, I just need to divide by 10 both sides. So we've got x equals minus 30 divided by 10 is going to be minus 3. Now x equals minus 3 gives us the x-intercept. So we know that the x-intercept is minus 3. What is the x-intercept? Well, it's where the graph will hit the x-axis. So it'll hit it at minus 3. I'm going to do the same thing again. But this time I'm going to cover up the x term. I'm just going to cover this up. And so we're going to end up with minus 3y equals minus 30. Again, put my lines in. And this time I'm going to have to divide both sides by minus 3. And so we've got a minus divided by minus, which is a positive. 30 divided by 3 is 10. So our y-intercept will be 10. Y equals 10. So that will be here. And we know that the minimum amount of points we need to be able to draw a graph accurately, well, to draw a graph are 2. So if we've got 2 points, we can draw a graph. And here we do have 2 points. So I'm just going to draw in this graph as best as I can. And make sure your graph goes for the complete graph. Then make sure your line continues on for the complete graph and don't just draw it between the x and the y intercepts. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, not right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here, and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times top 1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So this says find the probability of A or B. Now A or B means it can be in A, it can be in B, or it can be in both. So we add the 5, the 3 and the 12 together, and that gives us 20, and put that over the total amount. So that is these 3 added together, which is 20, plus the one outside here, which is 30. 20 over 30 is the same as 2 over 3. First thing we notice is that there is a square here, so we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of 2 shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these 3 here, and this one. So I'll say like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1600, take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. So here we're just adding the column vectors. So we're going to add the tops, so 2 plus the 5, and we're going to add the bottoms, minus 4 plus 6. 2 plus 5 is 7, minus 4 plus 6 is 2. So our answer will be 7, 2. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11. So we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. To find the interquartile range, we need to remember a simple formula, and that is that interquartile range is the upper quartile, take away the lower quartile. How do we find the upper quartile from a box plot? Simple, that is the bit here, which is 29. How do we find the lower quartile? It's just the bit here, which is 12. So use the formula, 29, take away 12, and that's going to equal 17. So the parts of a box plot is the lowest value is here, lower quartile, median, upper quartile, highest value. We're going to first of all get x equal to the 0.151151, blah, blah, blah. And what we need to do is we need to pull all of the recurring numbers in front of the decimal point, or at least one instance of them. So I need to times it by 1,000. So we're going to do that. Times it by 1,000, and we'll get 151.151.151, blah, blah, blah. What we're going to do now is we're going to subtract going So 1000x take away x would be 999x, and then 151.151151, etc. take away 0.151151, etc. will just be 151. Get our solving lines in, because the next thing we're going to do is divide both sides by 999. And so we end up with x equals 151 divided by 999, or over 999. And that's our answer. The first thing to notice is we actually have two radii here. So we've got this radius here and this radius here. And all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well. And we've got to write that down. So we're going to say angle OBA is equal to 19x. And the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here. And all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180. And let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now, there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees, because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, is just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. When you square root a fraction, you can actually just square root the top and square root the bottom. So square root of 9 is 3, square root of 16 is 4. So that is equivalent to 3 over 4. I'm going to start by identifying the equations of each line. So here we've got y equals 2, because the y coordinate is always 2 on this line. This one here we've got x equals minus 3. Because the x coordinate is always minus 3. And this next one is a bit more difficult, but it's perfectly diagonal, so it's going to be a y equals x line. But if you look, it crosses the y-axis at minus 1, so it's going to be y equals x minus 1. Okay, these are not inequalities though, so we need to work out what the inequalities are. So we're looking at the region, which is here, and we can pick a point in the region. I normally try and pick a nice easy one, so let's pick 0, 4. So 0, 4 is in our region. So 0, 4, let's compare that to our y equals 2. Well, what is that compared to 2? Well, it's actually greater than 2. So it's y is greater than 2. We have a look, the fact that our line is dashed, it's not going to be equal to 2, because it's saying it's not on that line. Okay, this next one, let's have a look at this. Well, is it greater? Is that 0 greater than minus 3? Well, yes, it is. So it's going to be x is greater than minus 3. Again, the line is dashed, so it can't be on the line. Now, this last one's a bit more difficult because it's got x and y in it. So we feed in the values. So for our coordinate that we've picked, x is 0 and y is 4. So 4, and I'm just going to put, I don't know, not equal to, but, or I'm just going to leave that blank, leave that as a box. And 0 minus 1. So all I've done is fed in the coordinate values into this equation. And I've got rid of the equals because what we need to do is work out what inequality it's going to be. 0 take away 1 is minus 0. So what is 4 compared to minus 1? Well, 4 is definitely greater than minus 1. So it's going to be y is greater than x minus 1. But if you look, this line is solid. It's a solid line. It's not a dashed line. Therefore, we're going to put a little line underneath it because it can equal it as well. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. There are loads of ways to solve a quadratic, but this is asking us to complete the square. So I'm going to start just by copying down the question. And when we complete the square, we're mainly looking at the x squared term and the x term. And to complete the square, you just put a set of brackets down with an x at the start and then half of the coefficient of the x term. So plus 30, with half of that would be plus 15, and then squared. If we quickly expand that over here, well, that's going to be the same as x plus 15 times x plus 15. X times x, x squared, then you get 15x, so that'd be 30x. And then plus 15 times plus 15 is going to be plus 225. So the problem we have is it creates a 225, so we need to remove that. So take away 225, then plus 4 equals 0. And then finally what we're going to do is just add those two parts together. So that would be minus 225 plus 4 to be minus 221. Right, let's get our lines in because we're going to solve this now. And the first thing we're going to do is add 221 to both sides. And so that will be the x plus 15 squared is still there on the left hand side equals 221. Then we're going to square root both sides to get rid of that squared. So we have x plus 15 equals the square root of 221. And then we're going to take away 15 from both sides. And so we have x equals, so I'm going to put the minus 15 first. Now when you square root something, you can get a positive and negative answer. So we're just going to put a plus and minus before the square root, and then it's 221. So our answer would be minus 15 plus minus square root of 221. Now notice the format that it wants the answer does not have a square root at the bottom, so we are going to be rationalising the denominator with this. So I'm just going to write out the question, just so we've got a start. And notice here we've got this 6 plus root 2. Now you might think you rationalise the denominator by timesing top and bottom by root 2, and that would get rid of the root 2 there, but it would actually create a 6 root 2 at the bottom, so it won't rationalise the denominator. The trick here is, imagine that the bottom here is a bracket, and what you want to do is times top and bottom of this fraction by the same bracket, but with the different sign, the opposite sign in the middle. So instead of 6 plus root 2, it's going to be 6 minus root 2. So we're going to have 6 minus root 2. Okay? And when we do that, we can imagine that there's going to be brackets at the top as well. We've got 2 plus root 2 and 6 minus root 2 at the top. And then we've got the 6 plus root 2 and the 6 minus root 2. Now, the reason why we do that is you will see when we expand the bottom one, but I'm going to start with expanding the top one, and it doesn't really matter which method you take to expand it. I'm just going to use the grid method because it's a little bit clearer maybe. And so we've got 2 plus root 2, and we've got 6 minus root 2. So 6 times 2 is going to be 12, and that's going to be 6 root 2 minus 2 root 2, and then that would be minus and a positive is a negative, and then root 2 times root 2 is just going to be 2. And so when we add these two together, we're going to get 10. When we add these two together, we're going to get plus 4 root 2. And I'm going to now do the bottom one. So this one was this expansion here, and I'm now going to do this expansion here, and we're going to do it down here. And so we've got 6 plus root 2 and 6 minus root 2. So 6 times 6 is 36, 6 times root 2 is 6 root 2, 6 times negative root 2 is just negative 6 root 2, and then we've got a minus and a positive make them negative, and then root 2 times root 2 is just minus 2. And so when we add them together, we've got the 36 and the minus 2 there, so that would be 34. And then 6 root 2, take away 6 root 2, is just going to be nothing. So that actually expands to be an integer, not a surd. And that's why we picked the opposite sign, is because whenever we do that, we get rid of the root 2, and we just get a nice number at the end. Okay, so when we put those in, and we end up with 10 plus 4 root 2 at the top, which is our answer here, over 34, which is our answer here. And let's just make that a bit nicer. There we are. And that's our answer down here. Now we're looking to see whether we can cancel at all, and if you look, we can actually divide everything by 2. So divide the bottom by 2 and we get 17. Divide the 10 by 2, we get 5, and we've got to divide all 3 terms by 2, so we get a 2 there. So we actually end up with 5 plus 3, 5 plus 2 root 2 over 17. So our missing numbers, looking back at the question, A would be the 5, B would be 2, and the C is 17. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx, the function, the kx plus 2. We're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2, and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. We've got to subtract 1 outside the function, so all that means is we move the graph down 1. So instead of here, it's going to be down 1. Instead of here, it's going to be down 1. this bottom bit here will be somewhere down there, and just everything will be down 1. So it's not that easy to sketch, but we'll try our best to sketch it out. And we want to draw exactly the same graph, just down 1. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.